Hello, my name is Steve Bowler, and in this video we're going to be taking a look at firewall filters. Specifically within firewall filters, I'm going to show you how to create a basic firewall filter. And this is Juniper Firewall Filter Lab number 1. So if this network topology looks familiar, this is the same network topology that we used for BGP Lab 1. And so what we're going to do to prove the concept of a firewall filter, we're going to use the same network topology. And if you haven't seen that video, I highly suggest that you watch it. It's very informative. And also I'll just go ahead and run through the network topology real fast, and then we'll go ahead and jump right into the firewall filter lab. So we have 3 routers, router 1, router 2, and router 3. They are connected together. These are all logical systems on one physical Juniper router, and they are connected together using logical tunnels. All of these routers have logical tunnels LT120, and then for instance the connection between R1 and R2 is LT120.12, and then R2's connection to router 1 is the .21, router 2's connection to router 3 is the 23, and router 3's connection to router 2 is logical tunnel -120.32 or unit 32. Router 1 has a loopback 0.1 with 2 subnets on it, the 1 network and the 11 network, and router 3 has a loopback 0.3 interface with the 3 network and the 33 network on it. Again, when you are using logical systems and connecting them via logical tunnels, we cannot have just the loopback 0.0 on all of the routers. Each router has to have a different loopback, and that's why we have loopback 0.1 on R1 and loopback 0.3 to represent router 3's loopback. Router 1 is in Autonomous System 100, Router 2 is in Autonomous System 200, and Router 3 is in Autonomous System 300. For the purpose of this lab, autonomous systems and BGP is not the case that we're trying to prove. What I'm going to show you is how to configure a basic firewall filter, how a basic firewall filter works, and we're going to use some show commands to verify the operation of the firewall filter, and also we're going to use a trace option within BGP on R2 and show you a couple things using the trace option once we apply the firewall filter to router 3. So router 3 is where we're going to be doing the most or the majority of our configuration. It's going to have the firewall filter applied to its logical tunnel interface inbound. So that is where we're going to place the firewall filter, and I should start off just giving you a background on a firewall filter and what it does, and its purpose is to control packets going through a router's interface in either the inbound or outbound direction. So if this sounds familiar and you are familiar with the Cisco IOS, a firewall filter closely represents an access control list that you configure on a Cisco router or switch or firewall or device. You can also do more things with firewall filters, but that is what I'm going to prove to you in this lab. You can also use firewall filters as a counter, and when it's used as a counter, it can be used to count specific packets, and that can be very helpful when you're trying to troubleshoot connectivity issues or reachability issues. So a firewall filter is applied under a specific interface, just like an access control list. So for instance, we're going to put it on the logical tunnel interface, and a firewall filter is placed under the logical interface. So it's not placed on the physical interface. We're going to see that we can put it under the family iNet, or we can also put it on the IPv6. We can put it on different families. So what I'm trying to say is the different logical interfaces can have more than one firewall filter applied to it. But you can only apply one inbound and outbound firewall filter per family. So if you're using INET 0 for IPv4, you can only apply one inbound and outbound. But if you're also using an IPv6 family, INET 6, then you can also have one inbound and outbound as well. So again, these can only be applied on the logical interfaces and not to the physical interface itself. So that's enough so far. Let me go ahead and we're going to dive right into this. This whole network diagram is already pre-configured. The links between R1 and R2 is the 12 network, and the links between 2 and 3, router 2 and 3 is the 23 network. So let's go ahead and get into router 3 and start the configuration of a firewall filter. So the first thing we're going to do is if we're going to log in as though we were actually getting into router 3, so we'll do the command set CLI logical system R3, and this is going to put us at router 3's command prompt. Our operational mode, I should say. Now let's go ahead and get into configuration mode. And the first thing that we're going to do, and what we're going to see with firewall filters, is that they are similar when we are creating them to routing policies within the Junos. And if you're not familiar with the routing policy or how that is created, you can go ahead and take a look at my routing policy lab 1, where I define the basics of routing policies and show you how to implement them. So if you have not seen that video, it's very important to understand there are 4 parts to creating a firewall filter. You have to create a name for your firewall filter, and then you create a term, and within your term is where you have your match option and your action option. So you're going to match on a specific instance or option. In this case, we're going to match on IP address, and once we have matched a specific IP address, we're going to give the firewall filter a specific action to take. So let's go ahead and get started. If I do edit and then space question mark, you see that we have an option for firewall, and that is what we're going to use to configure our firewall filter. So we're going to do the command edit firewall, and then if I do a space question mark, you see that we have an option for filter, and this is to define an IPv4 firewall filter, and that is exactly what we're going to do. We're going to be matching IPv4 packets in this example, so we're going to do the command edit firewall filter, and then it's going to give us the option for a filter name. So in this case, in this example, let's go back to our network diagram, and I'm going to explain to you exactly what we're going to do. What we're going to do in this example is we are going to create a firewall filter to match on packets sourced from router 1's 11 network destined to router 3's 33 network. And if these packets are matched, not only do they have to source from router 1's 11 network and be destined to router 3's 33 network, but they have to, we're going to specifically put in here to match the protocol of ICMP. So what I'm going to show you in this lab is we're going to ping from R1 to R3 before we apply the firewall filter, and we're going to be successful, and then once we apply the firewall filter, we're going to block ICMP traffic, so our ping will then fail. I'm going to show you how to set this up and how to monitor other traffic flows as well. We're also going to show you some very basic foundations and things that you need to know with firewall filters in regards to their default behavior. So more to come on that later. Just wanted to let you know that is what we're going to do in this lab. So we're going to give our firewall filter a name, and our name for this firewall filter is going to be called block ICMP. So we can go ahead and hit enter, and now we are under the edit firewall filter block ICMP. So if I do a question mark from here, what we're going to do now is we're going to set up our term. Our first term we're going to call T1. The way we're going to do this is with the set option. So we're going to do set term, and then again we can name it anything that we want. So for simplicity, I'm just going to call it T1 for term 1, and then if I do a space question mark, this is where we have some options. And our first option that we're going to use two options from this list. We're going to use the from and then. Again, the from is going to be our match statement, and then our then option is going to be our action that we are going to take, as we can see here. So first we're going to match the source subnet of the 11 network off of R1, so we'll do set term T1 from, and you can see we have many options to choose from. We're going to use the source address in this lab. So we're going to do the option set term T1 from source address, and if I do a space question mark, it's going to ask us for the prefix to match. In this case, we're going to match the 11 network, which is the /24. Again, if we go back to our network diagram, from router 1's point of view, it is advertising into BGP the 11 network, and that is the /24. So we're going to go ahead and match that as our source, and we'll go ahead and hit enter. So now that we have, if I just do a show now, you can see that our term T1 has been created, and our first match is from the source address of 11.11.11.0/24. So we're also going to include another match option within this term, and this is going to be on the destination address. Again, remember I said we're going to match the destination, so any traffic going from the 11 network to the 33 network matching protocol ICMP we want to drop. And this is our first firewall filter lab. So I just want to show you some of the basics with firewall filters in this lab. So we're going to do the set term T1 from, and then if I do a space question mark, you can see that up here at the top we have a destination address option. So we're going to match an IP destination address. Set from, and then destination address, and then it's going to ask us for our prefix to match. In this case, it's the 33 network. Again, this 33 network is a /24, so we'll go ahead and put that in and hit enter. So now if I do a show command, our term T1 has the match from the source address of the 11 network to the destination address of the 33 network. And we are not done yet. Again, what we have to do is match the protocol under the term T1. So we're going to use set term T1 and then from, and we're going to use the protocol option, And the IP protocol type that we're going to match, if we go ahead and hit protocol and space question mark, we're going to match ICMP. And that should be it. So now we have all of our match criteria set. The next thing that we're going to do is tell the firewall filter what to do when this criteria is matched. And in this case, we want to just go ahead and reject or block this traffic. So we're going to do the command set term T1, and then instead of using from, we're going to use then, and we'll use the command reject. You can also use discard, but for this lab we'll go ahead and use reject. And that is our first term that we have. Again, that term was named T1, where we have 3 match criteria, and if all of these criteria are matched, then we're going to reject this traffic. And if I were to go ahead and apply this firewall filter to the interface, what's going to happen is not only is this traffic going to be blocked, but all other traffic will be, because by default the firewall filter will discard all traffic if it does not match a term within the firewall filter. So we don't want to leave it like this. We need to set another term for all other traffic that's going to match all other traffic. And we're going to do this very easily. We'll just do the command set term T2, then accept. So now if I look at my firewall filter, term T1 is going to be where we block ICMP from the source and destination of the 11 to the 33. And then our term 2 is where we're going to accept all other traffic. So what I'm going to do is I'm going to start a ping on R1. It's going to do a ping of 1,000,000 or something so that it doesn't time out on us. So when I start this ping, I'm going to go ahead and get it started and show you how the network is reachable from the 11 to the 33. We're going to source it from the 11 to destination at 33. Let's go ahead and get this going. So I'm at the router 1 command prompt. So if I do a show route, you can see that I have reachability to the 33 and the 3 network. So I'm going to go ahead and ping 33, 33, 33, 33 from the source of the 11 network. We're going to do a rapid ping with a count of a lot. So I'm going to let this go, and I'll go ahead and minimize this. So that we can see this traffic going through. And then we will go back to router 3. And there's one last thing I need to do, and that is to apply this to an interface. Just like an access control list, a firewall filter, we're going to apply this to not a filter. We're going to apply this firewall filter to an interface. So let's go ahead and go to the top of the configuration. And the command that we do this, again, we're going to do this from router 3's perspective. We're going to do this on the logical tunnel 32 interface. So let's go back to router 3. We're going to do the command edit interfaces LT120 and then again unit 32. So now that we're under the interface, the logical tunnel on R3 pointing to router 2, we're going to do the command set family. Again, when we're talking about firewall filters, we can apply multiple firewall filters to the interface, but it's the logical interfaces that we can do this on, not the physical interface. So that's why we can specify set family and then iNet, iNet6, MPLS. So we can specify multiple firewall filters inbound and outbound on multiple logical interfaces. For instance, we can have two firewall filters inbound and outbound for iNet or for IPv4, and then also we can have a firewall filter inbound and outbound on iNet6. So we're going to do the command set family iNet, and if I do a space question mark, see that I have an option for filter. So we're going to use this again for packet filtering. Set family iNet filter, and then do a question mark. We're going to apply this filter inbound to R3. And we're going to do that with the input statement. We also have output. If I do a question mark, it's going to ask us for our filter name. So this is where we're going to put block ICMP. Just like earlier when we named it, we named our firewall filter block ICMP above. So we're going to go ahead and add that in. Hit enter. So we'll go to the top of the configuration, and this is the moment of truth. So let's go ahead and commit, and then we'll see what happens. On R1 we're going to be looking at this, and now we can see that right away we are getting the statement communication prohibited by filter. So obviously this is not working now. It's giving us an error message back. I could also change this. If I go to router 3, and let me just show you something real fast. So I'm going to go into firewall filter block ICMP. If I do a show, let's do this. We'll do set term T1 then discard. So I'm going to go ahead and start this again. And now if I go ahead and commit this, now you can see we're not getting anything back from R3 at all. This traffic is being discarded altogether. It's not coming back with the communication prohibited by filter anymore. So this obviously, if you don't want anybody even knowing about that it's getting reachability back to your router or your interface, then this would be the best way to do it, would be to discard it altogether instead of reject it. Because the reject sends the message back saying communication prohibited by filter. If I discard, obviously you can see now we're not getting that at all. So it looks like our firewall filter, our basic firewall filter, is working correctly. We did a source ping from router 1's 11 network to the destination on router 3, which is the 33 network, using ping, which is ICMP, and you can see that once we applied our firewall filter inbound to the LT32 or the logical tunnel 32 interface on R3, we can see that we are not unable to reach that anymore. However, if I were to go to router 1, what's going to happen if I try to ping and I source it from the 1 network? Let's go ahead and see what happens. On R1, if I do a ping to the 33 network and then just source it from the 1 network. So 1.1.1.1. And as we can see, we have reachability. And this is because in our firewall filter on R3, the only thing that we are matching on R3 is the destination of the 33 network and not the 3 network. So all other traffic, all other ICMP traffic is going to be allowed through, except if it comes specifically from the source of the 11 network to the destination network of the 33. So that's the basic example of how to set up a firewall filter, how to create it. Again, there's 4 things that you have to do. You have to give your firewall filter a name. You have to create a term, and then under the term you have to have your match statements and then your actions. Let's go ahead and show you one more thing. What I'm going to do is get onto router 2. As we can see, we're under router 2 right now. And I'm going to do one more example is we're going to use, and we're going to block BGP traffic inbound to router 3. So let's go ahead and set up R3. We'll create another firewall filter. We'll do edit. Let's do this, top. Then we'll do edit firewall filter, and then we're going to name it block BGP. So under this firewall filter, what we're going to do is, just like the name sounds, we're going to block all the BGP traffic. So the BGP neighbor relationship, if I'm on R2 right now, and if I do a show BGP summary, you can see that we have a neighbor relationship with R3, and we've been up for over 30 minutes. If I do a show route, you can see router 2 is learning the 3 and the 33 network with the next hop of router 3, which is 23.3. So what we're going to do with our firewall filter this time around is, instead of showing you how to block based on source and destination addresses, I'm going to show you how to block from a protocol. Or, I'm sorry, we're going to block using a port, and the port is going to be BGP, which is 179. So we are under edit firewall filter block BGP. Our first term we're going to set is set term T1 from, and this is our match statement again. If we go to the bottom, you can see we have the port option, and this is going to allow us to match TCP UDP source and destination port. So we're going to do set term T1 from port, and then if I do a space question mark, you can see that we have at the very top the option for BGP, our Border Gateway Protocol. And that's all we're going to do. So once we have matched the port of BGP, which is 179, we're going to then reject this traffic. So that is our first term. Our second term is, again, there's an implicit deny all at the end of our firewall filter, so we have to allow all traffic through that does not match this first term altogether. We're going to do that with the command set term T2, and then just put in then accept. So let's go ahead and commit, save our changes. And now that this is saved, let's go to router 2, and I'm going to create a trace option. And if you don't know what a trace option is, it's going to allow us to log messages, kind of like a debug IP would on a Cisco device, it's going to allow us to log these messages and view them real time with the monitor start option. So we're going to log them using creating a file, then we're going to create our flags, and then we're going to monitor this traffic on R2, see if we can see what's going on. Again, I have a trace options lab. You can go ahead and watch that if you're not familiar with it. We'll do the command set protocols BGP trace options. I'm going to name the file, we'll just name it let's go ahead and name that BGP for simplicity. So now that we have our file created, we're going to do the command set protocols BGP trace options flag, and this is where we're going to be able to flag these events and send them to our log file. We'll just do all events. And again, if we want to view this, we just do show log space question mark. Should be able to do BGP. Let's do this. Show log, var log. Oops. Did I not commit that? Thought I committed that change. Let's try this. Let me try one more thing. Sorry about that. Let's do this. Set logical systems R2 protocols BGP trace options file, and we'll just name the file BGP. And then we're also going to do trace options. We're going to flag all events. So now that we have that, if we do a show log, let's do this. Show configuration logical systems R2, and R2 we should see the trace options, and we do under protocols BGP. We have the file BGP and flag all. Let's do this now. Let's do set CLI logical system R2. If we do a show log, let's see. Do not see that under there. Let's do this. Monitor start. And looks like we're having some problems trying to figure out our trace options. And I know that we were able to do this earlier. Let's try one more thing. Let me try set protocols BGP trace options. We'll just name it a different file. We'll just do firewall filter. going to do the trace options, we'll do flag all events. So we'll commit and quit. Under R2, if we do a show configuration, you can see that we have under BGP we have trace options, named firewall filter, and the flag all. So if I do a show log, there we go. So if I do a show log firewall filter, now you can see that we are getting BGP log messages. So I knew I wasn't going crazy again. I created it called BGP, and you all saw that, right? It did not create it, but once I created it and under the firewall filter name, you can see that we are successful. So let's do this. We can also view this in real time if we do the command monitor start and then follow that up with the file name we just created, so firewall filter. So what this is going to do is show us in real time these BGP events as they get processed. As we can see by the following output. So let's do this on R3, and like I said, I'm doing this all for a reason. I want to show you some really cool stuff. So let's do this. On R3, if I do a show, we can see that we have the firewall filter named block BGP. Under the term T1, we're going to block everything from the BGP port, which is 179. We're going to block all that traffic, or we're going to match that traffic with the from option. Once we do that, we're going to reject it using the action of then. Then our second term, which is T2, we're going to accept all other traffic. So I'm going to show you exactly how we're going to use this. If I do a show interfaces on R3, you can see that right now our inbound firewall filter is block ICMP under family INET for for our unit 32. Let's go ahead and change this. We'll do set interfaces LT120, again unit 32. Family is going to be INET IPv4 filter, and then inbound. So our inbound filter, if I do a space question mark, it's going to ask us for our filter name. So this is where we're going to put in the filter we just created, which is called, if you don't remember, it's always good to go back up in your configuration, just highlight it. So it's just called block BGP. So now that we have that under the interface, we can do a show pipe compare to see the difference. We're going to, and like I was telling you earlier, this is a great thing to know right here, is you can only have one firewall filter inbound per logical, not per logical interface, but per family. So in this case, for family INET, or for IPv4, our IPv4 filter of block ICMP was automatically taken off once we added the block BGP filter. So this is where you can see you can't have both of these filters on at the same time under the same family of IPv4 or INET. So let's go ahead and commit this. Then we should be getting, we'll get some good stuff above on R2 in just a second. On router 3, if I do a show BGP summary, you can see that it still shows that we have our neighbor adjacency with router 2 right here. It still shows it up, and that's because the hold down timer has not expired yet. So once that happens, let's send in keep alives to R3, but router 3 is not going to receive these because it's blocking all traffic on port 179, which is BGP, as you can see listed right here, 179. So you can see these keep alives are being sent, but nothing's being received. And there you go. I don't know if you saw that. Let me go ahead and do a monitor stop to stop all the real-time traffic. Now if I do on R3 a show BGP summary, you can see that our neighbor went active, and we all know, if we've all troubleshot or dealt with BGP before, that is not a good sign. That is very bad for BGP to go into active. And we can see from our debug output, our trace option I should say, is that we have a notification received from, which is router 3, which is 23.3, and the code 4 is hold timer expired. So we all know that our hold down timer has expired. So on router 2, if I do a show BGP summary, we can see that our neighbor adjacency to router 3 is now down as well. We are seen active. So if I do a show route in router 2's routing table, we do not have reachability to the 3 networks. The 3 network or the 33 network anymore. So let's go ahead and test our firewall filter from router 2's standpoint. Let's see if I can still ping 23.23.23.3, which is router 3, and you can see that we are successful. So what I'm going to show you, and you might be wondering, well, why are you doing this? Good question. What I'm going to show you is the default policy. If we take off this term on R3, if I do a show configuration, what I'm going to do under the firewall filter block BGP, the term T2 I'm going to take off, and I'm going to show you exactly what happens, what the default action of a firewall filter is if we don't have this showing to accept all other traffic, the second term. So let's do this. We'll go under Edit Firewall Filter Block BGP. We're going to do set term T2. Actually, we'll just do this. We'll just do delete term T2. Now we'll do a show, and you can see that we only have one term, which is T1, which is to block port 179, which is BGP, our reject. Let's go ahead and commit this. And right away you can see once we did that commit, we lost reachability to router 3's interface. And that is because if we do a show on R3, under our filter block BGP, we no longer have term T2, which allowed all other traffic except for BGP traffic. And so our ping, that's why our ping was successful before. So once we took off that term T2, what I wanted to show you is the rule of the implicit deny all at the end of the firewall filter. So it's very important that if you're creating a firewall filter to deny traffic, that you get that traffic denied, and then if you want to accept traffic, that you put in an implicit permit any, pretty much at the end, or accept all other traffic. Because if you don't, as you can see, all that traffic is going to be denied with the implicit deny all. So you have to be very careful when creating your firewall filter. Okay, so there's a lot that you learned in this lab, and there's a lot going on that I wanted to show you. Again, what you can also do on the router that you created the firewall filter, you can do the command show firewall and hit enter, and you can see that we have the two filters that we created, which was block ICMP and block BGP. So there's some options you can use to show the firewall options, so like show firewall log, nothing there right now, or show firewall counter, and we're not counting anything right now, even if I put in, say, R3 block BGP, we don't have a counter name. So we'll show you that maybe in a later lab, but I just wanted to show you right now some of the default properties of firewall filters, how to create a basic firewall filter. So I hope you've learned a lot from this video, and I hope to see you in the next one.